One of the brightest stars you can see in the night sky is slowly dying, and for more than a century, astronomers have been trying to understand one of its strangest secrets. Now, powerful new observations are giving scientists a closer look at what is happening around Betelgeuse, the enormous red star positioned on the shoulder of Orion. And what makes this story so incredible is that Betelgeuse may not be alone. A hidden companion has been suspected for generations, but because the star is so overwhelmingly bright, finding anything close to it has been almost impossible. That changed when astronomers finally got the right combination of predictions, technology, and observations. And what appeared beside the giant star was not exactly what researchers had expected. It was larger than predicted, powerful enough to disturb the atmosphere around Betelgeuse, and potentially connected to some of the strange behavior astronomers had been watching for years. Even more fascinating, the James Webb Space Telescope is now giving scientists an unprecedented infrared view of the star itself, allowing them to study dust, gas, and enormous eruptions that cannot be understood properly through ordinary visible light observations. So what exactly is happening to Betelgeuse? And why has this famous star suddenly become one of the most interesting objects in our sky? Let's start with the star itself, because the numbers are almost impossible to imagine. Betelgeuse is a red supergiant located roughly 650 light-years away in the constellation Orion. Unlike most stars that require a telescope to see, Betelgeuse is bright enough to observe with the naked eye. During the winter months, it appears as a distinctive reddish-orange point on Orion's upper left shoulder. Human civilizations have been seeing it for thousands of years. Ancient skywatchers observed it long before modern astronomy existed. The constellation of Orion became part of numerous cultural traditions, and the reddish star has remained one of the most recognizable objects in the winter sky. Yet, despite all those centuries of observation, we are only now beginning to understand how extreme this star really is. Betelgeuse is not simply a large star. It is enormous on a scale that makes ordinary comparisons almost meaningless. Our sun already seems gigantic when we compare it with Earth. More than 1 million Earths could fit inside the sun by volume. But if Betelgeuse were placed where the sun currently sits, its outer atmosphere would extend enormously outward, reaching toward the region of the outer planets. Earth would be buried deep inside the star. Mars would also disappear beneath its surface. Even the asteroid belt would lie within its enormous outer layers. Jupiter, the largest planet in our solar system, would be somewhere near the outer edge of the expanded stellar atmosphere. Estimates place Betelgeuse at hundreds of times the sun's diameter, with its enormous outer envelope extending across an astonishing distance. And despite being relatively cool at its visible surface compared with hotter stars, it radiates an extraordinary amount of energy because of its immense size. But there is another fact that makes Betelgeuse especially important. It is a dying star. Stars this massive do not live forever. They burn through their nuclear fuel far more quickly than stars like our sun. Eventually, the balance that has held the star together begins to fail. When a massive star reaches the end of its evolution, its core can collapse and trigger a catastrophic explosion known as a core collapse supernova. In a fraction of a second, the center of the star can collapse under its own gravity, producing a shockwave that tears through the outer layers. The result can briefly become brighter than enormous numbers of ordinary stars and can shine with extraordinary intensity across interstellar space. If Betelgeuse eventually explodes as a supernova, it would become one of the most spectacular astronomical events humanity has ever witnessed. It could become visible during the daytime and remain extraordinarily bright for weeks or months. At night, it could dominate the sky. People would not need telescopes or specialized equipment to see it. Anyone standing under a clear sky would be able to look up and witness the death of this enormous star. But there is a major problem. Nobody knows exactly when that explosion will happen. Astronomers know that Betelgeuse is approaching the final stages of its life, but approaching in astronomy can mean something completely different from what it means to a human being. The star could explode thousands of years from now, or it could take much longer. The uncertainty is enormous. For a long time, there was no reason to believe that anything dramatic would happen in our own lifetime. Then, in late 2019, Betelgeuse suddenly did something that got the entire astronomical community watching. The star began to become dramatically dimmer. Between roughly October 2019 and February 2020, its visible brightness dropped by more than 2/3. The star that had been among the brightest objects in the night sky suddenly became noticeably faint. Amateur astronomers noticed it. Professional observatories noticed it. News organizations around the world began reporting on it. And almost immediately, one question took over the conversation. Was Betelgeuse about to explode? For a short period, people genuinely wondered whether humanity might be witnessing the beginning of a supernova. Telescopes were directed toward Orion. Researchers began analyzing the star from every possible angle. Several explanations were proposed. Perhaps an enormous dark region had appeared on the surface, similar in concept to a sunspot, but vastly larger. Perhaps the star's normal pulsation cycle had changed its apparent brightness. Perhaps material had been thrown away from the surface and had created dust that blocked our view. And while some researchers were cautious, the possibility of a supernova naturally captured the imagination of the public. Imagine looking into the night sky and watching one of the most familiar stars suddenly disappear into darkness, only to realize it might be preparing to explode. But Betelgeuse did not explode. Instead, by the spring of 2020, its brightness began to recover. Slowly, the star returned toward its previous appearance. The dramatic event was over, but astronomers were left with a new mystery. What had actually happened? The answer turned out to be far more interesting than simply saying the star had become dim. Evidence suggested that Betelgeuse had experienced an enormous surface eruption. Deep inside a red supergiant, hot material moves through giant convective cells. Imagine boiling water, except instead of a pot, imagine a star hundreds of times wider than the sun. Enormous bubbles of superheated plasma rise from deeper layers, reach the surface, and then cool and sink again. In Betelgeuse, these convective processes can operate on a gigantic scale. One particularly violent event appears to have launched a tremendous amount of material away from the star. Scientists have described this phenomenon as a surface mass ejection. The amount of material involved was enormous. A massive plume of plasma was expelled into space, and as that material traveled away from the star, it cooled. Heavy elements and silicate material could condense into dust. That dust then became capable of blocking some of the visible light coming from the star. From Earth, the effect was dramatic. We were not necessarily watching Betelgeuse become permanently weaker. We were watching a giant cloud of material move into our line of sight, an obscure part of the stellar surface. In other words, Betelgeuse had effectively thrown material into space and then hidden behind some of its own debris. Researchers were astonished because a surface mass ejection on this scale had not previously been observed in such detail on a normal star. The event showed that massive stars can lose enormous amounts of material in sudden episodes, and it gave astronomers a rare opportunity to observe the aftermath of stellar activity while it was happening. But that was only the beginning. For decades, astronomers had noticed another strange feature in Betelgeuse's behavior. The star does not simply brighten and fade randomly. Its brightness changes in cycles. One well-known period lasts roughly 400 days, associated with the star's natural pulsations. But there's also a much longer variation that has puzzled researchers. A cycle lasting several years appears in the brightness record, and ordinary pulsation alone does not completely explain it. That raised an intriguing possibility. Perhaps something else was orbiting Betelgeuse. Maybe a smaller companion star was gravitationally bound to the red supergiant. If such an object existed, its gravitational influence could affect the surrounding material and potentially contribute to some of the star's long-term brightness variations. The idea had been discussed for years, but there was an obvious problem. Betelgeuse is unbelievably bright. Trying to detect a faint object directly beside it is like trying to see a tiny candle while staring directly into a giant furnace. The overwhelming light of Betelgeuse makes a nearby companion extremely difficult to observe. Astronomers searched, but no companion could be conclusively identified for a very long time. Then researchers began combining decades of brightness measurements with orbital models. In 2024, independent research teams proposed that if a companion existed, they could estimate when it would reach the part of its orbit where it would be farthest from Betelgeuse from our perspective. That would create a rare opportunity. At maximum angular separation, the companion would be slightly easier to distinguish from the overwhelming glow of the red supergiant. The predicted timing pointed toward December 2024. That gave astronomers something incredibly valuable. Not just a theory, but a specific date and location to search. An astronomer then used one of the most powerful ground-based observing facilities available, the European Southern Observatory's Very Large Telescope in Chile. The instrument used for the observation was SPHERE, a system originally designed for extremely high-contrast imaging, including the search for faint companions and exoplanets around bright stars. Instead of trying to photograph Betelgeuse in the ordinary way, astronomers could use specialized techniques to suppress the star's overwhelming glare and examine the region immediately surrounding it. The data required extensive processing. The researchers had to separate the faint potential signal from the enormous brightness of Betelgeuse itself. There was always the possibility that nothing would appear. The companion might be too faint. The models might be wrong. The signal could disappear inside the noise. But when the processed observations were examined, something appeared near the predicted location. A faint source of light was detected where the models had suggested a companion might be. The hidden object had finally revealed itself. The suspected companion was no longer merely an idea in a mathematical model. It had become an observational target. And then came another surprise. The companion appeared to be more massive than earlier theoretical estimates had suggested. Instead of being roughly comparable to the mass of the Sun, Estimates indicated that it could be several times the mass of our Sun. That difference matters. A larger companion is easier to detect than a very small one, but it also means its gravitational influence could be more significant. The object quickly became associated with the informal nickname Betel Buddy, because it appeared to be the long-suspected companion traveling around the enormous red supergiant. But finding the companion raised an even more interesting question. What is it actually doing to Betelgeuse? Because this companion may not be sitting at a safe distance like a planet orbiting the Sun, models suggest that its orbit can take it through or extremely close to the extended outer atmosphere of the red supergiant. If that is correct, the companion would be moving through an enormous sea of stellar gas. And when an object moves through gas, gravity can create a wake. Think of a boat traveling through water. The boat pushes material aside and leaves disturbed water behind it. A similar effect can occur when a compact stellar companion moves through the outer atmosphere of a giant star. Its gravitational influence can pull and disturb the surrounding gas, creating a dense trail or wake. Observations from the Hubble Space Telescope have provided evidence consistent with such disturbances around Betelgeuse. This makes the companion much more than an interesting footnote. It could be actively interacting with the atmosphere of the star, and if that is true, the hidden companion might help explain the mysterious long-term brightness cycle that has puzzled astronomers for generations. As the companion travels through its orbit, its gravitational interaction with the surrounding material could influence the distribution of dust and gas. At certain points in the orbit, material may be redistributed or cleared from our line of sight, making Betelgeuse appear somewhat brighter. At other times, dust and gas could become more prominent, affecting the amount of visible light reaching Earth. Suddenly, a long-standing mystery begins to look less mysterious. A hidden companion could be part of the explanation. But there's an even more dramatic possibility. Could the companion have played some role in the extraordinary dimming event of 2019? Scientists are not claiming that this has been proven, but the question is now worth investigating. If the companion passes through or near the extended atmosphere of Betelgeuse, its gravitational influence could potentially disturb the star's outer layers. Could such interactions trigger or amplify the enormous convective activity that eventually produces a surface mass ejection? Could a gravitational disturbance contribute to the chain of events that led to the giant plume of material expelled in 2019? These are still open questions. The evidence is not strong enough to say that the companion caused the great dimming, but the possibility makes Betelgeuse even more fascinating. And this is where the James Webb Space Telescope becomes especially important. Webb is not simply taking ordinary photographs of Betelgeuse, it observes infrared wavelengths, allowing astronomers to study forms of light that cannot be seen by human eyes. Infrared observations are extremely valuable when studying dusty environments because different infrared wavelengths can pass through or interact with dust in ways that visible light cannot. This means Webb can investigate structures around Betelgeuse that may be hidden or distorted in ordinary optical images. The telescope can also help scientists examine temperatures, gases, dust, and the enormous convective processes taking place across the star. And what those observations reveal is almost impossible to imagine. Betelgeuse's surface is not smooth. It is not a calm red sphere. The star is violently dynamic. Giant convective cells rise from its interior, reach the visible surface, cool, and sink again. Some of these structures are comparable in scale to entire stars like our Sun. The surface is constantly moving. Material is being transported upward and downward. Gas is being thrown outward. Dust forms and spreads. The star is effectively living through a continuous cycle of stellar weather, except this weather occurs on a scale of hundreds of millions of miles. Webb gives astronomers a chance to follow some of that activity in infrared light. Researchers can study the material that Betelgeuse has already expelled, including dust clouds and gas shells surrounding the star. Those shells are like records of the star's past. Every major eruption leaves material behind. Over long periods, those layers accumulate around the star. In a sense, the surrounding nebula becomes an archive of previous episodes of stellar mass loss. If we can determine the structure and composition of those shells, we can learn how the star has changed over time. That is one of the extraordinary advantages of observing a massive star before it dies. We are effectively watching the final chapters of stellar evolution while the process is still happening. Webb can examine the crime scene before the final event occurs. And there is another reason these observations matter. Astronomers recently gained an important reference point from the observation of another red supergiant that eventually exploded. In 2025, researchers studied a supernova in a distant galaxy and were able to examine images of the star before its explosion. The progenitor had been surrounded by significant amounts of dust. Visible light observations struggled to reveal it clearly, but infrared observations provided information that could pass through the dusty environment more effectively. That result is especially relevant to Betelgeuse because Betelgeuse itself has produced enormous amounts of dust throughout its life. If it eventually explodes, that surrounding material will become part of the story. An infrared telescope such as Webb could observe the explosion and its aftermath in ways that previous generations of astronomers simply could not. If Betelgeuse explodes while Webb is still operating, humanity could receive an unprecedented scientific record of a nearby massive star dying. We could watch the evolution from the earliest stages of the explosion through the interaction of the blast with surrounding material. We could analyze the chemical elements produced and expelled by the star. We could study how the explosion interacts with the dust and gas already surrounding it. And we could observe the aftermath in multiple wavelengths. But before we imagine that event, there is one important question. What would actually happen if Betelgeuse exploded? The core collapse itself would happen extraordinarily quickly. The star's core, supported for millions of years by the balance between pressure and gravity, would suddenly become unable to resist its own weight. The central region could collapse from a size comparable to Earth down to something only tens of kilometers across. The collapse would produce an enormous burst of energy and launch a shockwave through the outer layers. Those layers, containing hundreds of millions of miles of stellar material, would be thrown outward into space. From Earth, the star would brighten dramatically. Within a relatively short time, it could become visible during daylight. At night, it could cast noticeable shadows. It could become one of the brightest objects humans have ever seen in the sky. And unlike a normal celestial event that lasts seconds, the visible supernova could remain bright for an extended period. Eventually, the expanding debris would form a vast cloud around the remnant. At the center could remain a compact object such as a neutron star, depending on the exact conditions of the collapse. We already have examples of ancient supernova remnants that remain visible today. The Crab Nebula, for example, is associated with a supernova observed by humans in the year 1054. The explosion happened nearly 1,000 years ago, yet the expanding material can still be studied today. Betelgeuse could eventually leave behind its own cosmic monument. But there is an important piece of good news. Betelgeuse is far enough away that its eventual supernova is not expected to pose a serious biological threat to Earth. At roughly 650 light-years, it is much farther away than the distances generally considered dangerous for significant supernova radiation effects. So if it explodes, the event should be a spectacular astronomical display rather than a catastrophe for our planet. The biggest uncertainty remains the timing. When will it happen? The honest answer is that nobody knows. Estimates for the remaining lifetime of Betelgeuse vary widely. It could be thousands of years, it could be tens of thousands. It could potentially take much longer. The strange behavior we have observed does not provide a reliable countdown clock. A massive star can experience dramatic eruptions, pulsations, and changes without necessarily exploding immediately afterward. The great dimming of 2019 was extraordinary, but it was not a direct warning that a supernova was about to happen. What it did provide was something arguably more valuable, a rare opportunity to watch a massive star lose material on a scale never previously observed so clearly. And now, with the possible companion entering the picture, astronomers have another variable to investigate. Betelgeuse is not simply a dying star sitting alone in space. It may be part of a gravitational relationship with another star. Its outer atmosphere is moving and changing. Its surface is erupting. Its brightness varies on multiple timescales. Dust surrounds it. Gas is continuously escaping. And powerful observatories like Webb are watching all of it. There is something almost poetic about the timing. Human beings have watched Betelgeuse for thousands of years, but for most of that time, it was nothing more than a reddish point of light. Then we invented telescopes. We learned that stars are enormous spheres of plasma. We learned that they are born, evolve, and eventually die. We built space telescopes. We developed infrared astronomy. We created instruments capable of suppressing the glare of nearby stars. And now we can begin to see details that previous generations could never have imagined. We may have finally found the companion that was hiding beside Betelgeuse. We have observed the aftermath of an enormous surface eruption. We can study the dust created by material leaving the star. We can examine the enormous convective structures on its surface, and Webb can look through parts of the dusty environment in infrared wavelengths, giving us a view of the star that is fundamentally different from what the human eye sees. But there is one final detail about Betelgeuse that makes this entire story feel almost surreal. The light reaching us today does not show us Betelgeuse as it exists this exact second. It shows us the star as it was hundreds of years ago. At roughly 650 light-years away, the light we see today began its journey around 6.5 centuries ago. When that light left Betelgeuse, Earth was living through a completely different chapter of human history. There were no modern telescopes, there were no satellites, there were no computers, there was no James Webb Space Telescope. Human civilization looked at the same reddish star without knowing what was happening there. And there is an even stranger possibility. If Betelgeuse's core collapsed tonight, right now, we would not know about it for roughly 650 years. The explosion could already have happened, and the information simply would not have reached us yet. Or the star could continue peacefully evolving for thousands of years. From our position on Earth, we are trapped by the speed of light. We are always looking into the past. That means when Webb observes Betelgeuse, it is not literally seeing the star's present moment. It is receiving ancient light that has crossed interstellar space for centuries. And yet, through those old photons, we can reconstruct what the star was doing when that light began its journey. That is one of the most humbling aspects of astronomy. The universe operates on distances and timescales that make a human lifetime almost microscopic. But despite that, we have developed instruments powerful enough to study a dying star hundreds of light years away. We can analyze its atmosphere. We can measure its dust. We can map its changing surface. We can search for a companion hidden beside it. We can observe the material it throws into space. And we can begin to understand the final stages of a star that may one day end in a spectacular explosion. Betelgeuse has been shining long before humanity existed. It will continue changing long after the people watching it today are gone. But right now, for this brief moment in cosmic history, we are here to witness it. We are the generation with the technology to look deeper than ever before. And perhaps that is the most remarkable part of this entire story. Betelgeuse has been hiding its secrets in plain sight for centuries. The companion was there. The dust was there. The eruptions were there. The strange brightness cycles were there. The enormous convective cells were there. We simply did not have the tools to understand them. Now we do. And every new observation raises another question. Is the hidden companion responsible for more of Betelgeuse's strange behavior than we realize? Could its gravitational influence affect the star's future evolution? Could it somehow interact with the material that Betelgeuse is constantly throwing into space? And when the red supergiant finally reaches the end of its life, what will the final explosion actually look like from our planet? We do not know yet, but we are watching. And that is what makes Betelgeuse so extraordinary. It is not just a bright star. It is a laboratory for understanding how massive stars live, lose their outer layers, interact with companions, create heavy elements, and eventually die. The James Webb Space Telescope is giving humanity another set of eyes to study that process. Every image, every spectrum, and every measurement adds another piece to the puzzle. Maybe one day the star will finally explode. Maybe it will happen thousands of years from now. Maybe someone reading this will have descendants who witness it. But whenever it happens, the light will cross the darkness between Betelgeuse and Earth, and eventually someone will look up and see the sky change. Until that moment, Betelgeuse remains a warning and a wonder. A giant red star slowly approaching the end of its life, surrounded by dust and gas, possibly accompanied by another star, and constantly revealing new behavior to anyone capable of looking closely enough. So the next time you step outside on a clear winter night and see Orion rising, find that reddish point on the hunter's shoulder. Remember that what looks like a tiny dot is actually an enormous dying star, hundreds of times wider than our sun. Remember that something may be orbiting beside it, hidden for generations. Remember that the dramatic dimming of 2019 was not the star disappearing, but the aftermath of a colossal eruption. And remember that the light you're seeing began its journey centuries ago. You're not seeing Betelgeuse as it is today. You're seeing a message from the distant past, somewhere far beyond our solar system. That giant star continues to evolve, pulse, erupt, shed material, and move toward its eventual fate. And humanity has finally developed the technology to watch. If Betelgeuse has a hidden story, James Webb may be helping us read it one piece at a time. So tell me in the comments, did you know that Betelgeuse may have a hidden companion? And after seeing what this star is actually doing, do you think its eventual supernova could happen sooner than we expect? Or do you think we still have thousands of years before the final explosion? Let me know what you think. Share this video with someone who loves space, and the next time you look toward Orion, remember that one of those familiar stars may be hiding an entire system of secrets. And I'll see you in the next one.